This video is an introduction to the beautiful combination of our microcontrollers and the Raspberry Pi. It was later extended with IoT Stack, the easiest way to our home automation server without cloud. Grafana, InfluxDB and Node-RED on a Raspberry Pi form a dream team for visualization of IoT data. The setup is not easy, but this is what we will do together. Grüezi YouTubers, here is the guy with the Swiss accent, with a new episode and fresh ideas around sensors and microcontrollers. Viewers might remember my video about the visualization of weather data in Node-RED. I used the name porn because it was too much. Back then I promised you to show you a simpler method. So today we will install everything necessary on a Raspberry Pi using Peter Scargill's newest script. We will compare time series databases like InfluxDB with SQL databases and see their advantages for IoT. We will create an InfluxDB database and connect it to a Node-RED flow to read data from my weather station. We will create a Grafana data source to get access to the InfluxDB database. We will develop a dashboard with several panels showing the different weather data. We will see the power of a time series database combined with Grafana. And in the end, you can download a ready-made SD card for your Raspberry Pi. Based on what you learned today, you should be able to take the example and create a flow in Node-RED to store sensor data in InfluxDB and display it from there on a Grafana dashboard. Very important, the data is only stored in InfluxDB. Node-RED does only the conditioning and Grafana only the display of the data. A lot to do, let's start. As usual, first we have to copy Raspbian to an SD card. I use standard Raspbian without any additional software. Later, Peter's script will install what is needed. You should also be able to use Raspbian Lite if you do not want a desktop. Then we start our new Raspbian, do all required configuration and the standard update and upgrade to get everything on the latest status. Please do not forget to enable SSH if you want to connect from a remote PC to your Raspberry and to choose your time zone. You find a link in the description on how to set up your Raspbian. Now you can follow Peter's instructions to get his script and run it. In Peter's script you can select the programs you want to install. Here you see my choice. Do not choose Node-RED twice. I picked this one to install the newest version. Because I had some issues, I had to manually install Moment. I hope this will no more be necessary in the future. As a last installation step, we have to do some admin stuff for InfluxDB. First, we edit influxdb.conf using sudo nano. The only two lines we have to change are the HTTP enabled to true and the bind to the standard port. Then we have to create an admin user. Node-RED, InfluxDB and Grafana should now work. ifconfig shows the address of my Raspberry 192.168.0.12. We can test the installation by connecting with the browser to Node-RED on port 1880 and to Grafana on port 3000. Both use admin as credentials. In Node-RED you should already find many nodes installed. Also the node to connect to InfluxDB. Unfortunately, during my install, Peter's script had some issues and I had to install the InfluxDB node from the palette. I hope this will be solved in the future. But why do we use InfluxDB and not SQLite as in previous projects? What is the difference between the two? SQL databases like SQLite are very flexible and the workhorse of many business applications. They are organized in rows of data like time, temperature, humidity, wind speed, etc. If we want to store our sensor data in SQLite, we have to create a database, here called weather, a table called stations, and then add all needed fields, including their data types. Not a big deal. Then we can insert the sensor data line after line. InfluxDB, on the other hand, is a time series database. It is a relatively new sort of databases. They have a similar structure like SQLite. The difference is that a timestamp is automatically added every time we insert data, and we do not need to define the fields as we did before in SQLite. As we will later see, they are added as soon as we insert data into the database. So it is a little easier to work with a time series database. But this is not the most important difference. Much more important is the reading of the data stored in the database and how these new databases deal with historical data. What are typical questions we have for our sensor data? We are interested in, for example, all data for the last hour or the last 24 hours. Or we want to have average temperatures for all days of the previous year. What is common in all these questions? Time slots are always one part of the question. Time series databases are optimized for such queries. Of course, you also can create standard SQL queries to answer those questions. But this involves a lot of work. And you have to write all the different queries yourself. In contrast, look at the out-of-the-box choice here, overwhelming, without one line of coding. Precisely the stuff for non-programmers. And for guys like me, we like programming, but we love results. The second difference is how databases deal with historical data. My weather station, for example, creates data every few minutes. This real-time data is interesting for, let's say, 1 week. Later on, I am more interested in hourly, daily, or even weekly data. Standard SQL databases store and retain all data ever written to them. And to get the data for last year, they have to read all sensor data and create averages when you issue a query. This can create a heavy load and is slow, especially on machines like a Raspberry Pi with limited memory. Time series databases offer so-called retention policies, where you can decide how long you want to keep the real-time data and how the data should be averaged and compressed after that. You could, for example, decide you want to keep all sensor data for a week. After that week, you only want to keep hourly averages for a year. And after this year, only daily averages. You can imagine how much the database size will be reduced with such a retention policy, and how fast a query runs against this reduced dataset. The retention policy is only created once, and then the database does it automatically. This is why these time series databases are usually preferred for IoT scenarios, especially on small machines like a Raspberry. By the way, why do I use Node-RED, InfluxDB and Grafana? There are other software packages to choose from. The first reason is cost. All 3 packages are open source and free to use for makers. The next reason is support. Most of us anyway use Node-RED in one or the other way for our projects. And for the moment, the combination of InfluxDB and Grafana is on everyone's lips. So you get a decent community support. And it's supported by Peter's script, also an advantage. Let's now look at how we get our data from the sensor into the database. I use the same flow as in video number 242. The flow parses a MQTT message from rflink and creates the following message 433 object. This object contains all sensor data like temperature, humidity and wind speed. It also includes the name of the sensor. Because most of you do not have the same weather station, I added an inject node that you can simulate my weather station. Like that you can play with this setup even if you do not have sensors attached. At the end of this flow, we use an ordinary function block to create the needed message for the InfluxDB connector. The rows in InfluxDB are mapped for each variable: name, temp, wind, etc. The message 433 variables are the ones created by the flow from the sensor. The next node inserts these fields into InfluxDB. Because Node RED and InfluxDB run on the same machine, we can use 127.0.0.1 or localhost as address and port 8086 as defined earlier in the setup of InfluxDB. We call our database weather and use the credentials of our Pi user created before. And we use the measurement stations. Done. Of course, we get now errors because no database exists. This is what we have to do next. It is quite simple. We log into our Raspberry and open Influx, the client to the database. Then we create our database. Now, Node RED does not create any errors anymore. If we look at measurements in our database, we see that Node RED automatically creates the measurement stations. And if we ask for the fields, we get the automatically created fields, including the data types like string or float. Everything done automatically. And if we query the stations, we see already filled data from our weather station. Cool. Now we are ready to fire up Grafana on its port 3000. We add a new data source and fill in these parameters: a name and a type, the default address, and the basic authentication for InfluxDB. Then the name of the database we created before and the credentials again. Now we are ready to test the connection. Next we can go back and start to create our first dashboard. We call it weather. Of course, it is empty till we add a panel. The first is outside temperature, and we edit the panel data. The source is our only measurement called stations, and because our weather station has the name DKW 2012, we have to put this information into the where clause. We do not want to read data from other sensors like the XT200 or the Oriole. SQL lovers can look at the query inspector to see what happened. Now we select the temp field and select mean to get an average value. We select group by time and select 5 minutes as the time to average. We give it the name roof temperature and go on to define the axis. For the y-axis, we choose degrees Celsius and a label. Next, we add a label with the current temperature. Like that, we always see the last value. And we can remove filling to get a better readability of curves. This is especially important if you want to display more than one curve in a panel. Done and back. Our first panel is finished and can be named and saved. The wind panel has 2 curves, one for the wind speed and one for the gusts. You create the first measurement and copy the second to save time. The last number on the dashboard is the wind direction. It is a gauge, not a line graph. After a day or so, the dashboard looks like that. We can now freely select the timescale to display the details and even choose a particular period with a mouse. To get all this running was not a simple task and took some time. This is why you can download a copy of my SD card image and, using Win32 Disk Imager, create your card for your Raspberry Pi 3. The user and passwords are Pi and Raspberry, admin and admin, and user and user. I used an 8 GB card. If you use a 16 GB card, it should be okay, maybe even with an 8 GB card. Of course, you can do much more with Grafana and also define retention strategies with InfluxDB. With this first installation, you have a working example where you can do your tests. Of course, also add your own sensors in Node-RED, as I did it with my YouTube statistics, where I created a whole new Node-RED flow, a different database, and a new dashboard. Summarized, we installed the needed software using Peter Scargill's newest script. We know the difference between time series databases and SQL databases. We created an InfluxDB database and connected it to Node-RED to read data of my weather station. We connected Grafana to InfluxDB. We developed a dashboard with several panels showing the weather data. We played around to see the power of a time series database and Grafana. And you got a ready-made SD card to easily start your experiments. I want to especially thank Peter and Antonio for their work on the script, and also my supporters on Patreon and viewers using my links for their purchases for supporting the channel. Without you, it would be difficult for me to do what I do now. Bye!